All right. If you guys switch on, then we'll start the session, guys. Okay, going ahead. Some more people have to switch on the webcams. Still not here? Vishal, Deepesh, Rohan, etc. Switch on the webcams. All right. Who is that? Okay, now. So what we learned is this IP flows have to kind of need to be mapped into QoS flows. Now we have to see things related to how this mapping works. Who need to take care of this mapping? If you take a look at this QoS flow, there are some interesting things that we'll observe. QoS flow is kind of between mobile all the way up to UPF. Of course, in the middle at G node B, the QoS flow is being carried on the data radio bearer and it kind of need to be shifted to N3 tunnel in the uplink direction, or in the downlink direction, the QoS flow need to be shifted from the N3 tunnel to the data radio bearer, the opposite. So that means we have multiple tasks that we are identifying. Because the QoS flow is between mobile to UPF, in the uplink direction, mobile need to kind of do the mapping. Whenever the IP packets are generated, it need to kind of inspect the IP packets and detect, find out which IP packets or which IP flows need to go on which quality of service flow. So mobile side protocol software have to do the job of mapping the uplink flows onto uplink quality of service flows. Once mapping, E node B on the sending side, it need to shift the quality of service flow from a data radio bearer to a tunnel, N3 tunnel. And then once it is received at UPF, UPF would be sending this out. UPF will find out, will kind of do the billing activity related to the QoS flow, and then it would send it out. But what is going to happen in the downlink direction? IP packet flows arrive. UPF need to inspect the IP packets, IP packet flows. Once they arrive at G node B need to shift these QoS flows from the tunnel to their respective data radio bearer. In some cases, multiple QoS flows would be put onto one data radio bearer. In some other cases, it could be one-on-one. One QoS flow would be put onto one data radio bearer. In other case, two QoS flows are getting mapped onto one data radio bearer. So it need to shift from N3 tunnel to data radio bearer. N3 tunnel is on NGU interface between G node B to UPF to G node B. Here we call it as a UU interface between G node B to the mobile on the radio interface. We have data radio bearers. We have to shift. And then once received, the data would be sent to higher layer. The QoS flow data, the IP flows would be extracted and would be IP packets would be sent to the higher layers. Higher layers would deal with them. Okay. What G-node we have to do in the middle, we will study that once again. Okay. So how these filtering mechanisms work? What need to be, how do we identify which IP packet should go on which QoS flow? So first we are having a look at how this happens or how this takes place at UPF and UE. First we are having a look at UPF, how it happens. UPF would be doing this mapping in downlink direction when the traffic is coming from internet or packet data network into our radio telecom network that time. So UPF is responsible for implementing quality of service flow segregations by inspecting the incoming downlink IP packets. So there can be many IP packets that would be arriving for the mobile from different application servers. If mobile is using 5 applications, there are 5 application servers that are sending the downlink traffic to the mobile. Like you have opened WhatsApp, you have opened YouTube, you have opened something else, something else, something else. 5 applications. All the applications are servers are sending some amount of data. Everything would be sent in the form of IP packets. So you will receive several IP packets. But UPF is responsible for inspecting these IP packet headers and find out which IP packet should go on which QoS flow. So it will apply the filtering criteria. First filter, segregate each UE's traffic. UPF would be dealing with thousands of subscribers traffic. Maybe under your telecom network, there are 1 lakh subscribers. UPF is receiving the IP packets that belongs to each one of those 1 lakh subscribers. First, it need to segregate at UE level, which traffic belongs to which subscriber first. That can be kind of very easy to do. You can do that with the help of destination IP address that would be pinpointing to the UE's IP address. That means the internet servers, when they are sending the data to 1 lakh mobile subscribers, in the IP packets, they would be using 1 lakh different IP addresses. Because for every subscriber or every mobile phone will have a different IP address. So the IP packet would be addressed to a different address. So by looking at that IP header information, IP address information, UPF will be able to segregate, okay, this traffic is for UE1, this traffic is for UE2, this traffic is for UE3, maybe this traffic is for UE 1 lakh, last 1 lakh UE subscriber. So first you will do UE level segregation. And for every subscriber, there is a tunnel ID. There is one tunnel created for every subscriber. So based on that IP address of the subscriber, you have identified the UE, and then you are identifying the corresponding tunnel ID that you have to use to send to corresponding G-node B. Now, remember, all the 100,000 subscribers or 1 lakh subscribers may not be under the same G-node B. They may be under many G-node Bs, but wherever they are present, under whichever G-node B, there will be definitely a tunnel ID present. Typically, tunnel ID is going to be separate for separate G-node Bs. So this tunnel ID plus the IP address of the G-node B also will be identified along with it. So UPF kind of can decide by using which tunnel I have to send this traffic to which G-node B on what tunnel ID. For every subscriber, G-node B would have created a tunnel ID. If, for example, G-node B is dealing with 500 subscribers, receiving 500 subscriber related data, there might be 500 tunnel IDs created. So you might have to identify that specific tunnel ID applicable for that particular subscriber. So this is the first level filter that takes place at UPF. Now, second level filter, segregate each UE's data into quality of service flow traffic. So after you segregated one UE's traffic, you might have identified IP packets arriving from 5 different application servers. Simple point of view belongs to 5 different IP flows. Now you have to identify which IP flow data need to be sent on which QoS flow. If there are, for example, in the picture we have seen, there are 3 QoS flows present. So on which QoS flow we are going to send this traffic? That is what the UPF will have to identify. For that, what information it is going to use? At IP level, it would be using source IP address. For example, from which IP address this is arriving. For example, if it is arriving from Facebook, you already kind of identified for Facebook which quality of service flow is working. So with the help of that IP address, you can detect. Or at IP level itself, you have protocol identifier, which identifies what is the next level protocol, like what is the transport level protocol. Or at the IP level, we have the DSCP information, DSCP marking related details, which talks about the quality of service class markings. Like we have studied this in our first session, IP quality of service marking. Based on the IP quality of service marking, also you can detect these IP packets belongs to which quality of service flow. So there are several filtering properties at IP level. Those of you who have not enabled the webcam, not a worry. They will ask you for swapping at a later point in time. So it will work in a swapping mode for till you will solve this issue. So after some time, you can, some people will disable the camera, you will can enable the camera. But those of you who have enabled, keep it. Okay, anyway, you follow the instructions from the admin team. So they will be talking to you. So based on it, you can enable it. Okay. I'll not disturb the flow session again. You can continue with the instructions sent from the team. On. Okay. So by using this IP level filtering and transport level filtering, transport level, you have the source port number and destination port number. Source port number or source port number range, or destination port number or destination port number range. These filters are available in order to detect this IP packet is exactly arriving from which application and belongs to which application server. Which port number identify which application, IP address identify which application uh, server from the traffic is arriving from. So with the help of that, you would be able to segregate the IP traffic. Uh, I don't know whether you remember this or not. Um, I'll show you this. Uh, it's not about compression, but if you take source port is mobile side and destination port is application server side. Similarly, we have source IP address and destination IP address at IP level. So again, if it is uplink, source is mobile, destination is application server. If it is downlink IP packets, source is application server, destination is mobile. So with the help of these port numbers and these IP addresses, by making them work as filters, you can identify which IP packet would be falling under which quality of service flow. So basically, UPF will have that knowledge of identifying which IP addresses present in with the IP packet or which port numbers, etc., belongs to which quality of service flow. Somebody will provide these details to UPF. By using that information, UPF will be able to segregate the traffic, the IP traffic that belongs to one particular subscriber. It will be able to segregate it into multiple different QoS flows. And then it'll have to send it out on that particular QoS flow in that particular tunnel of that particular subscriber. Now, who sets these parameters? How does the UPF know like which IP address data or which port number data should go, which belongs to which application or which IP flow, and which must be mapped onto which QoS flow? How UPF knows that? That part we will learn later. This how UPF will get it. But somehow we are taking it for granted at this point in time that UPF knows these details that about these mapping rules, like which IP packets with what parameter values must be mapped onto which QoS flow. Those are known to UPF. By using that rules, UPF is doing this filtering. Similarly, in the uplink direction, UE does that. UE, by inspecting the UE doesn't need to identify tunnel ID because it in uplink it is directly going to transmit on the radio link or by using radio bearers, data radio bearers. Here we don't have tunnel concept. So at UE level, all the data belongs to single UE only in uplink, but the data would be going to different servers. If you are using 5 applications generating 5 different IP packets, each of those IP packets may be targeted to send towards different application servers. So the filtering criteria on the UE is by looking into each and every IP packet and their IP level headers, like what is the destination address and protocol identifier and DSCP marking, or at transport level by looking at the port numbers, source port number, destination port number, etc. The mobile software would be able to detect which IP quality of service flows, uh, IP flows must be sent on which QoS flows. So if there are 5 IP flows, there are 3 QoS flows, you kind of determine with the help of these parameters. Again, we are taking here for granted that mobile already know these rules about which IP packets generated towards which their IP address or with what port numbers should be put onto what QoS flow. These rules are known to the mobile. Who sent those rules to the mobile equipment? Right now, we are not worrying about it. We are taking it for granted that mobile already knew those rules. With the help of those rules, it is doing the filtering, the identification of IP flows to the QoS flows. Now, these filtering mechanisms of identifying IP packets belongs to which QoS flows will be considered as NAS filters, SDF templates, or we can call it sometimes as traffic flow templates, or QoS rules, or NAS filters. In different places, in different circumstances, one of those names would be used. SDF stands for service data flow rules, or service data flow template. A template which you are following kind of gives you information about the template tells you which IP packet should go on which QoS flow. Or traffic flow, how the traffic is flowing, traffic related template. Template means a known format, like known set of IP addresses and port numbers in your IP packets determine which IP packet should be sent on which QoS flow. Or can be called as QoS rules, or they can also be called as NAS filters, non-access stratum level filters, or non-access signaling level filters. The filters which are identifying IP packet to QoS flow mechanism. Okay, is this first part clear? Have you understood this first part? Okay, great. I'm taking that silence as yes. Now the second part. These QoS flows, they need to be mapped onto now radio bearers. This is the second level part. So we already identified which IP flows would be going on which QoS flows. But now we have to identify which QoS flow should be mapped onto which data radio bearer, should be sent on which data radio bearer. This need to be done at two places. One side at mobile and the other side at G-Node B. So we already identified which IP packets are going on which flow. But now we have to identify which flow will go on which data radio bearer. So one QoS flow can have one separate single data radio bearer, or multiple QoS flows can share one data radio bearer. Both are allowed in 5G. So this identification in the uplink, mobile need to do it in uplink. And in downlink, when the traffic is being shifted from N3 tunnel, when the QoS flow arrived on one single N3 tunnel, because all the QoS flows arriving on one tunnel itself. But when that is getting shifted to radio, they are going to get shifted to corresponding data radio bearer. So these two things would be sent on one data radio bearer, and this QoS flow would be sent on this data radio bearer. So QoS flow to DRB mapping. This QoS flow to DRB mapping should be done in uplink by the mobile and in downlink by G-Node B when it is shifting the traffic from N3 tunnel to data radio bearer. So this is second level filtering, second level rules. First, we study G-Node B. G-Node B does QoS flow to data radio bearer mapping or basically, but it will be performing this mapping in both directions, in downlink as well as in uplink. First, what does it do in downlink? In downlink level 1, first it separates each UE's packet data on the basis of on which tunnel ID the data arrived. Because G-Node B might have created 500 tunnel IDs for 500 subscribers. So it is very easy for G-Node B to easily detect the data belongs to which user based on the tunnel ID on which the data is arriving. All the IP packets that are arriving in the downlink from the UPF to G-Node B, they are kind of packed in the GTPU protocol, tunneling protocol. But in the GTPU protocol, you will have this tunnel ID added. With the help of the tunnel ID on which the traffic is received, you can easily detect which IP packet should go to which mobile. Now, on the tunnel that you are receiving, you will have information about the quality of service flow, that IP packets should go on which quality of service flow. The details would be sent by already by PGate, your UPF. Because UPF is already detecting which IP flows need to go on which quality of service flow. It kind of conveys that information to G-Node B also while it is sending the traffic on the tunneling. It conveys the details. So the G-Node B, by the time it receives the IP packet on a tunnel, it knows that IP packet belongs to which QoS flow. The only thing G-Node B need to do is that QoS flow traffic should be sent on which data radio bearer. So it kind of need to map that. So your QoS flow will have an ID. Now, how G-Node B knows that mapping? Somebody would have already told G-Node B about it. Who is that somebody? Right now, we don't care about. But we are taking it for granted that G-Node B already knows these rules, which QFI need to be sent on which DRB, which data radio bearer, or on which data radio bearer, which QFI arrives. So G-Node B knows that. So because G-Node B already knew those rules, it is simply applying those rules. And once it arrives, data arrives in the tunnel, with QFI ID. With the help of it, it can identify on which radio bearer you have to send the traffic. You give it to the corresponding PDCP entity, um, so that the PDCP entity process it, and corresponding quality of service mechanism would be implemented by the MAC layer and would be sent out. That is how it works there. Now, first we study, this is the downlink case, where the traffic is arriving from uh, UPF to G node B. We study uplink. First, we study uplink part on UE side. So, uplink UE responsible for mapping. Already QoS flows it has identified with the first level filters, the previous one we have studied, which IP packets belongs to which QoS flows, mobile identified, detected by inspecting the IP packet, IP addresses, port numbers, etc. Those details. By looking at it, it identified that. So because it already identified the QoS flow ID, so somebody might have already told UE this QoS flow to DRB mapping, it will do that. So which QoS flow data need to be sent on which DRB. So UE knows those rules. Based on it, UE would give that quality of service flow data to the corresponding PDCP. The corresponding PDCP starts processing it. But remember, somehow mobile will include when it is sending the data on the DRB ID, because there is a possibility DRB can carry the data of multiple QoS flows that is allowed. So you have to definitely, when you are sending the data, you have to include the QFI ID, quality of service flow ID, whenever you are sending the data. So noting down the ID is needed. You need to send that QFI ID all the way up to G node B, while the data is getting traveled on the DRB data radio bearer. But once the G node B receives the UE's QoS flows on a DRB data radio bearer, it will kind of extract the quality of service flow from the DRB ID. And because it has the QFI available, quality of service flow identifier available, uh, attached by the UE, by using that QFI ID, G node B will identify the tunnel ID by using which it will have to dispatch the traffic to UPF. So there will be a single tunnel that is applicable for all the subscribers together. Sorry, um, for all the quality of service flows together for a single subscriber. For every subscriber, one tunnel ID would be created by the UPF. So you have to identify that uplink tunnel ID that is carrying the mobile's data in uplink towards the UPF direction. So you have to pack this QoS flow traffic into that tunnel with that particular tunnel ID and send it across to the UPF. So UPF kind of receives that and deals with it. It then forwards it further. Once it receives that, it's going to send it out by doing the billing operation once the UPF receives that. But here the important point is this QFI is kind of a single entry that is traveling all through the path, quality of service flow identifier. So this QFI mechanism, which QFI the data is getting carried on, is need to be detected between mobile to G node B to UPF in uplink. It need to be detected from UPF to G node B to the mobile in downlink. So to carry this QFI ID along with that, whenever the IP packets are traveling, is important, because this QFI ID only will segregate the traffic in the intermediary node level, and that will only give you will be able to achieve the perfect quality of service that is required. This QFI ID. Identifying the QFI ID is done by the mobile and UPF. Mobile in uplink direction, UPF in downlink direction. But how eNodeB knows what traffic it is receiving, either in uplink or downlink, or how the traffic belongs to which QFI ID? GNodeB doesn't know. GNodeB need to get this QFI ID. So how GNodeB gets this QFI ID? Once the UE and UPF detected the QFI ID by inspecting the data. Only who are inspecting the data is mobile in uplink direction, UPF in downlink direction. You need to remember that. UPF in downlink, identifying which IP packets belongs to which QoS flow, identifying the QFI ID. UE in uplink direction, which IP packets belongs to which QoS flow. But this information carrying it to G node B is important because G node B need to do the swapping. That QFI ID also need to be carried for various purposes. So for that reason, they are using two additional protocols while carrying the user plane traffic. So in downlink and uplink, what happens? In downlink, when the IP packet arrives, P gateway performs the quality of service rules implementation, inspect each and every IP packet header, detect which IP packet belongs to which QoS flow. It will detect the QoS flow ID and it will pack that QoS flow ID information into a protocol called as PDU session user plane protocol. So with the help of this PDU session user plane protocol header, UPF notes down this IP packet data belongs to which QoS flow. It will note down that. And this header, along with this header, this IP packet would be put onto the tunnel, N3 tunnel, by using the IP tunneling mechanism, would be put on inside it, and then it would be sent to the G-Node B. G-Node B receives this data, this tunnel data, and once he opens the tunnel, it will be able to find out this PDU session user plane protocol header information in it. So G-Node B reads the QFI ID from that, the detected QFI ID by the UPF for these particular IP packets that are arriving on this single tunnel, because all the user data is arriving on the same tunnel, belongs to whatever the QoS flow it is. But individually, for each QoS flow, different IDs will be there. That IDs will be noted down here in this protocol. Once GNodeB receives it, it identifies that QFI ID, and once it identifies, it kind of packs that QFI ID information into a protocol called as SDAP. Service Data Adaptation Protocol, it is called as. So the information will be shifted. The uh, PDU session user plane information, uh, whatever the QFI ID that is getting carried, that information would be shifted to the SDAP protocol. SDAP protocol will be shifted sends that data on that radio bearer, on those corresponding radio bearer. So two quality of service flows, it is sending on the one radio bearer, one quality of service flow, it is sending on the other radio bearer. After receiving that information, mobile equipment will remove that SDAP header and will be able to extract the original IP packets out of it, and then they would be sent to your applications. That is downlink operation. In uplink operation, everything would be reversed. It starts with the mobile in uplink mechanism. Mobile kind of does the first level filtering, identify which IP packets belongs to which QoS flows. It will note down that QoS flow ID in the SDAP header, in the SDAP protocol header. Then the SDAP protocol is going to be processed by PDCP, RLC, MAC physical, the receiving physical MAC, RLC, and PDCP. Finally, GNodeB receives that SDAP header. In that, there is a quality of service flow ID. Now, the SDAP header would be shifted to PDU yes UPP header. It would be shifted. So the quality of service flow ID shifted from this protocol to this protocol. After adding that header, along with that header, the IP packet would be packed into tunnel, the N3 tunnel, and then it would started getting forwarded on the QoS flow, and it goes to reach out to the UPF. So UPF, when it receives the traffic, it can detect the traffic arrived for which QoS flow. The reason why the uh, UPF need to detect that is for which each QoS flow, the billing rules could be different. That means if two IP packets arrive on this flow, two IP packets arrive on this flow, two IP packets arrive on this flow, with the size being 1,000 bytes only, each one of them. Um, but their billing can be different. Their billing rules can be different because three different quality of services, they can be built separately, they can be built differently. So in order to detect what billing rule is applicable, you need to detect the data belongs to which QoS flow. So with the help of the PDU session user plane protocol header, the UPF can detect the arriving IP packet data on the tunnel is present belong to which QoS flow, and it will be able to do corresponding billing. And after performing the billing, no more we use any tunneling. IP packets would be sent as it is on the external bearer, independently. Each one of them would be traveling. So there is no combined concept in the external bearer. So the bundling mechanism of converting flows into quality of service flows, IP flows into quality of service flows, only works on the radio interface on the N3 tunnel only. Only in your telecom network, this mechanism works. And this is also to make sure whatever the quality of service they are providing in the radio, they same quality of service they will implement on the N3 tunnel as well. So to provide that, they use this mechanism. So these QoS flows, once identified, need to be noted down in the form of headers. So we have two protocols, and the information gets shifted from one protocol to the other in the swapping order, depending on it is uplink or downlink direction. If it is downlink, QFID would be shifted from PDU user plane user session protocol, PDU session user plane protocol to SDAP. In uplink, SDAP to PDUS UPP. Is this clear, everyone? Is this understood? Deepesh, are you available? Deepesh, Deepesh Chaudhary. Deepesh, can you please respond? Are you there or not there? I'm not able to hear you, Deepesh. You're not enabled your mic. Okay, Deepesh, you're not responding. I'm going to dismiss you from the meeting. Okay, there is a point in uplink how UE will filter the IP flow. Can you explain again? Doesn't is any direction, it is the same thing, uh, filtering the flow by looking at the IP packet related header information, IP addresses and port numbers. If I have to take you back to the previous thing that we have studied, for example, if mobile equipment is generating the IP packet, in this source IP address will be mobile equipment's IP address, UE's IP address. Destination IP address will be application server. Now, if mobile is generating 5 IP packets, which are being sent to 5 different application servers, there will be 5 different IP addresses here in the destination IP address. Is that point clear? Because mobile is generating IP packets which are being sent to WhatsApp. WhatsApp server address is different. Facebook server IP address is different. Face Google server IP address is different, YouTube server IP address is different, and so on. So every server's IP address is different. So because they are different, you can easily you can use that information, those IP addresses, to filter. Similarly, port number. If we are using 5 applications, WhatsApp, etc., you have 5 port numbers. One for WhatsApp, one for Facebook, one for everything. Every application will have a different port number in your mobile phone, even though the IP address is the same. Source IP address is the same. Destination IP address is different because they are being leading to 5 different servers. But source port number would be different for each application. Destination port number also can be different, 5 different port numbers towards 5 different servers. With the help of these IP addresses and port numbers, these combinations of IP addresses and port numbers will make the mobile equipment realize this IP packet is generated by which application and it belongs to which QoS flow. Is that clear? Have you understood that? Whoever asked that question. Rohan, why we need multiple DRB on the basis of QoS flow, but only one N3 tunnel for all the QoS flows for one G node bay? That's a good question, which we need to answer in a step-by-step fashion. We can't do it in one step. But the first step of the answer, I'll tell you, um, I will tell you today. Tomorrow, I will tell you the remaining half, N3 tunnel part. Tomorrow, I will explain. Today part, I'll explain DRB part. We require different DRBs because at MAC level, each DRB would be provided with a different quality of service implementation. It wanted to apply the filtering rules based on whose traffic it would like to send first. So it want to apply. So it wanted to have kind of different DRBs. For example, if this application generates 10 IP packets, if this 10 application generates 10 IP packets, assuming that each application is using a different radio bearer, when the information is kind of conveyed to the MAC layer, MAC layer understands that, okay, 10 IP packets are waiting in this radio bearer, 10 IP packets are waiting in this radio bearer. So there is some kind of a priority associated. Let us suppose that the priority of this guy is 5, the priority of this guy is 10. Definitely this guy is higher prioritized when compared with this. So when MAC cannot send both the guys data at the same time based on the amount of transport block size that is possible to be sent on the physical resources. Now MAC need to some kind of segregate. When it is segregating, it will be giving importance for this data and it will pull the data from this particular RLC, from this radio bearer specific thing. You will be pulling instead of pulling from here. Based on the priority, we are segregating. So radio bearers, different radio bearers for different quality of service flows. So this QoS flow priority is high priority. This QoS flow priority is low priority. So to provide different quality of service implementations for both of them, we needed to create 2 radio bearers. At MAC level, that prioritization is taking place. But what we did, we have considered this whole thing as radio bearer. We have converted them, to look into this kind of a format, the radio bearer. So whatever the Mac is definitely doing either in uplink direction or downlink direction, providing the quality of service. Now, I hope you got clarity about how the quality of service for different quality of service implementations. Why do we require 2 different radio bearers? That part I hope it is clear. But how can we use only one tunnel for all the quality of service flows together? That we will identify at the N3 tunnel level in tomorrow's session. Clear? First part is clear? Okay. So we go back. Sorry. Okay, next. So to note down these QoS flow IDs to travel across the telecom network, they have identified two protocols, PDUS UPP and SDAP. And the information would be shifted from one to the other at Gnode B, the intermediary component, where the QoS flow is shifting from tunnel to the bearer or bearer to the tunnel. Data bearer to tunnel, tunnel to bearer. These protocols also will exchange the information. Okay, now, when the mobile equipment is connected to only one data network, now this whole process will be working out. All the applications mobile equipment is communicating in this data network would be having something called as one PDU session. This whole thing, all the radio bearers plus the tunnels that are created, everything together, it is called as a PDU session. And that is the technical wording we use, PDU session. Actually speaking, PDU session gets established first. Our network elements talk to each other to create the PDU session. Once they agreed upon that, then they will individually create the required quality of service flows, and those quality of service flows need to be linked on to which data radio bearer, then which tunnel, etc. They will talk about that. Actually, PDU session comes first, but I am teaching it in the reverse order. So all this thing that mobile equipment is having towards a particular data network is called as a PDU session. If the mobile equipment have got this PDU session established, it can send its traffic, IP packets generated by different applications towards this data network. It can send these IP packets. Now, how many PDU sessions mobile equipment require?
One, sir.
In this particular case, um, we have only one PDU session towards one particular data network. Let us consider this data network as internet. So mobile is using its internet applications communicating with the internet servers like WhatsApp, Facebook, etc., etc. But in the world, there is not only internet as the data network, there are other data networks also are possible. For example, you have a PDU session containing data radio bearer, quality of service flow, connecting to a second data network, another PDU session. Now, why do you require a second data network? What is the second data network, and what kind of servers that would be present? For example, that second data network could be IMS, IP multimedia subsystem, or it could be some private network that the operator is maintaining and providing the services to you. For example, operator might have installed some games and gave a opportunity for the subscribers to you connect to those gaming servers and play the games. So when you use those corresponding game applications, you would be taken to that data network where the game servers are being hosted. They may not be part of internet. They may be a private data network being hosted in your operator network side. Any number of data networks can be there, but the single big data network that we know in the world is internet. But other than that also there would be other data networks. One other popular data network, for example, could be IMS. We already have introduced what is IMS in our starting session, IP multimedia subsystem, to make the mobile equipment, to help the mobile equipment make VoIP calls, voice over IP calls, or to perform some multimedia operations. We use that IMS network. So in case if we have mobile, not only connecting to internet data network, but it is also connecting to IMS data network, two data networks, then it requires two PDU sessions. In each PDU session, we have data radio bearers and N3 tunnel. Of course, I have missed N3 tunnel. Sorry for that. Yeah, N3 tunnel is definitely there, is missing in the picture here. N3 tunnel definitely would be present. So there would be N3 tunnel, and there is a data radio bearer, there is QoS flow. Of course, one need not be only one QoS flow. There can be one, it can be two, it can be three, or it can be 10 QoS flows, depending on how many number of applications the mobile equipment is initializing, and those applications require how many quality of service flows, how many of different quality of service implementations. And the dependent on that, you can create as many number of quality of service flows you want. But the number of PDU sessions are two. One PDU session towards one data network, another PDU session towards another data network. But in every PDU session, there can be some number of data radio bearers and one tunnel. Number of quality of service flows. Each quality of service flow can carry number of IP flows inside it, which we can call it as SDFs, service data flows, each one that is present inside. Okay. Our SDAP and PDU, yes, user plane protocol part need to be there now also. UPF to Gnode B to mobile. So they carrying the QoS flow IDs. And of course, mobile may have two tunnels in this case, many radio bearers, but two radio bearers operating for one data network, one data radio bearer operating for the second data network. How SDAP generate DRB IDs or QoS flow ID for PDUS UPP? SDAP is configured with the corresponding details. How it is configured, I will explain that. I told you that I will explain that part. I told you to just imagine that that is a given in my previous slides. I told that somehow mobile equipment know these rules of detecting which IP flows need to be sent on which which QoS flows would go on which data radio bearers. I have told you that that information is already somehow configured on both mobile Gnode B as well as UPF. So simply a mapping, and they could able to identify which IP flow need to go on which QoS flow sits inside which data radio bearer, and that data radio bearer or QoS flow is part of which PDU session. There can be multiple PDU sessions when mobile equipment is connected to multiple data networks. Okay. Now the obvious, so first we see some points related to these important points related to these PDU sessions, etc. And then we get into the topic, how these components would know about this information. So the first thing that we have to study, so we have a mobile data network. Mobile, in this particular picture, it is shown that mobile is allowed to connected to only one data network, but it is not mandatory. But if mobile is connected to one data network, it will have one PDU session. Inside PDU session, you can have many QoS flows. Now here the QoS flows that are shown have been numbered from 1 to 4, but you can observe one important thing. These QoS flows now are not identified with radio bearers or tunnels. Now that part is completely removed. So we are considering that that is a given. So we are only looking at QoS flows in this picture. So now radio bearer is gone, tunnel is gone, but you have to, they are there, but hidden. They are there working in the background in exchanging the traffic and information. Okay, so what are the rules? UE can have one or more PDU sessions. Every time mobile equipment is connected to a 5G network, it need to have at least one PDU session. That's mandatory. That means mobile must be connected to at least one data network. That is mandatory in 5G network. The moment you register with the 5G network, you must be connected to one packet data network. Having one PDU session is mandatory. Which packet data network you decide. It can be internet, it can be IMS. You choose which one you would like to connect to. But one for each data network, you can have a PDU session, one for each data network or one for each slice. There is a network slicing concept which we did not study. Uh, I kind of ignore that slicing part for you, which is not part of your curriculum. You can ignore that slicing part. Later, you can learn about it. Uh, but here right now, with the limited thing that I'm teaching you, so for each data network, there would be one PDU session. And if mobile connected to three data networks, there would be three PDU sessions like that. Now, each PDU session contain at least one QoS flow, minimum, each PDU session. Whatever the QoS flow that is created could be default QoS flow. What is a default QoS flow? Default QoS flow is one thing that is identified as default during creation itself, during configuration itself, and it can carry the data that belongs to all the IP flows of all the applications. Especially the basic needs of all the applications will be served by using such a QoS flow. Normally, when you are coming up for the first time and connecting to the internet, all applications that are present on your mobile phone will start doing their original sync up, like getting you notifications. WhatsApp will tell you totally how many messages you have. It will show notification bar, and different applications will show different notifications. So all of these applications started signing in with the in their corresponding internet servers. Gmail application will speak to Gmail server, Facebook application will speak to Facebook server, Instagram will speak to Instagram server, WhatsApp application speaks to WhatsApp server. The moment you switch on your data, now all these guys to exchange this minimum information, bare minimum details, they could utilize this default QoS flow, where the default QoS flow normally would be created with very low level quality of service implementation, and that is enough for sending very small amount of information with very less quality of service, because applications required to perform only very low level things at the starting. Only getting notifications are important things, and high level information, that's all. That's it, the applications would do. And for that, this default QoS flow is enough. But already you have created a default QoS flow which is being used by all the applications for their bare minimum tasks. But suddenly, by using WhatsApp, you started making a call. You started making a WhatsApp voice call or video call. Now, the default QoS flow that is already created is not enough. Now you need to be upgraded to a dedicated QoS flow, additional QoS flow, which is not default, because you now require a stringent quality of service, a good quality of service you require now. For your WhatsApp voice call, you need some guaranteed bitrate, 1 GBR you require. So for that purpose, so it must be done. So um, the quality of service flow implementation will take place. A special quality of service flow would be created for that sake. Now, uh, PDU sessions cannot share DRBs. So if there are multiple PDU sessions you have created for different data networks, they would be working on different DRBs. They must map on different DRBs. That is for the normal subscribers. But for the NB IoT devices, like IoT devices, Internet of Things devices, like sensors, small devices that are installed in the network, irrespective of how many number of PDU sessions they might have, they might still be able to use a single data radio bearer. They will not have multiple data radio bearers to make sure they work on less battery power, because they're IoT devices, very small devices. They won't be sending lakhs of bytes of data. Their data can be very small typically. So that's why. Anyway, we have not studied that NB-IoT part. You can ignore that thing. You can ignore that point. Later, when you are involved with that activity, that time you can understand what is that point really means. But for time being, you can ignore. First two points are important. There is at least one quality of service flow that could be default one, which could be used by all the applications to send any quality of service flows through it. Normally to send very small amount of information, like logging in into the servers or getting first level notifications. But whenever you require a good quality of service, you have to establish a new QoS flow with a dedicated QoS configuration. And different PDU sessions must be using different DRBs. They cannot share a single DRB. Next, QoS flow level rules. First UE level rules, next PDU session level rules, now QoS flow level rules. Now, at least one DRB you have to have for one QoS flow. One QoS flow can be mapped onto one DRB, or multiple QoS flows can share one DRB. That's also allowed. Share the DRB with other QoS flows. But for every QoS flow, DRBs can be shared, but tunnel is going to be single. So there is a single entry tunnel for entire PDU session. So if you have two PDU sessions, there will be two tunnels, two entry tunnels. If there is a single PDU session, then you will have a single tunnel. And all the QoS flows would be traveling on the tunnel. But when it comes to DRBs, either it is one-to-one mapping, QoS flow to DRB, or you can share them. So two levels of packet filtering, NAS level filtering and AS level filtering, these are named as. At NAS level filtering, which is done by UE and UPF, associate uplink or downlink packets to QoS flows. That is done at mobile side and on the UPF part. The second level filtering is AS level packet filters, uh, access signaling, which we call it as access signaling level packet filters, associate QoS flows to the DRBs, both in uplink direction as well as downlink direction, and they will note down that quality of service flow IDs when they are packing it into the radio bearers. And there is a probability one radio bearer can carry multiple quality of service flow information also. Okay. Now, obvious question, how these quality of service flows would be configured at mobile Gnode B and UPF? How do they identify which QoS flow would be mapped onto uh, which QoS flow is mapped onto which uh, or which IP flow mapped onto which QoS flow, etc. All right. So the QoS detection and implementation. When to create a QoS flow, how do you detect it? How do you implement it? Which components will play the role to implement it? If you remember this picture that we have studied, this is the 5G core network plus our radio network, and I have explained you these are the most important components that we have to see. So we have the mobile Gnode B, AMF, SMF, PCF, AF, UPF, and data network. Now, out of these components that are present here in this, I'm kind of going to take the components that are involved with this quality of service flow related operation. Only those components. So which components are involved related to quality of service flow implementation? Mobile is definitely involved. Gnode B is involved. SMF is involved related to quality of service flow implementation. PCF is involved. Application function is involved. UPF is involved. And of course, data network is also going to be there in that process. AMF is not involved in it. AMF don't care about session management. Session management, how many PDU sessions we have to create inside PDU session, how many quality of service flows are required. The duty of deciding is in the hands of SMF. SMF takes up that job. So AMF is kind of not involved in it. AMF only maintains the mobility and does the authentication, ciphering, etc. Those kind of stuff with the user. So how these involved components will play the role, how the process starts and how the process ends. Okay. So there are the components that I told you are involved in this QoS flow implementation and how the job is done. Now you can see arrows there from all these components one on one, and there are some numbers there. Again, as those numbers, what is the meaning of those numbers is listed on to the right hand side in the right hand side bottom part. So there are 4 steps in the entire quality of service flow process, and those 4 steps are identified over here. So we see step by step. First, we are going to see step 1, SM subscription data. Step 1 is between the UDM and SMF. Normally during the registration, mobile, when it does the registration with AMF, AMF kind of talks to SMF. SMF will go and talk to UDM, which is a database in 5G network, gather subscriber details, subscriber session management related details, or session management related rules and details it gathers. Okay, now that is the first step. So that means SMF already got to know what and all the different quality of services that are allowed for this particular subscriber. That at least that session management information is available with the SMF. What kind of sessions can be created? PDU sessions can be created for the subscriber. What are the different rules that are applicable for this particular subscriber? In the second step, there is a request for the quality of service. But the second step can be initiated by many different places. It need not be initiated from exactly one place. It can be initiated from many places. For example, one step, mobile can go and speak to SMF, ask the SMF that, hey, I need a quality of service flow with a particular quality of service. It can request. Mobile can request from the SMF. That's one way. By using the NAS protocol messages, it would talk to SMF. Of course, not directly. If mobile will have to reach to SMF, mobile need to go through Gnode B, AMF, and then SMF. Even though the arrow is shown directly, but it have to go through all these components. But ultimately, mobile can request SMF. It can send a message to SMF that, hey, I need a quality of service flow. Suddenly, the subscriber opened the application and started generating huge amount of uplink traffic. To send that uplink traffic, I need a quality of service flow. It kind of can demand SMF for that. Or mobile can convey this information to a function called as application function that is present in your telecom network. If such a possibility is there for the subscriber, it can speak to application function. Tell the application function that, hey, application function, listen, I need one new quality of service flow. I'm not telling this to the SMF. I'm telling it to you. I know that you can take care of it. So this application function is one thing. When provided an information, it can kind of trigger the creation of the quality of service flow. But from which and all entities it can receive this triggering? Either from the mobile it can receive the triggering, or from the application server in the data network can speak to this application function and tell the application function that, hey, whatever the application mobile is using, for that application, the mobile requires some quality of service implementation. So I'm telling you, you please talk to the components that are involved. So your application server kind of can tell this to application function. Now, if it is the downlink traffic, normally downlink traffic is originated by the application server. So application server tells this to AF, telling that, hey, I need to send some 2 GB of data to subscriber. To send that, definitely subscriber requires a quality of service implementation, I'm telling you. So application server talks to application function, convey that information. What quality of service is needed for sending this much amount of downlink traffic. Or if it is uplink traffic, mobile equipment can either directly speak this with the application function in this second step, or mobile can go and speak to application server. If this interface is not available, this mobile to application function interface is not there, mobile can convey this information to application server. Hey, I wanted to send some 2 GB of data in uplink, or I wanted to start uplink, live broadcasting, for example, like there is an event going on, there is some kind of a cultural event going on, you wanted to uh, broadcast that cultural event to all your friends. So you started live streaming, uplink streaming. So mobile requires huge quality of service based on the uh, video it is generating. So it kind of conveys this information to application server. Hey, at what rate I'm generating the video is set to whether 1080 pixels or 720 pixels or whatever the data rate that the set by the human. Based on those estimates, it can convey this information to application server by sending one simple IP packet. Hey, I require so and so quality of service to dump this much amount of uplink traffic. It tells the application server, whichever application server you are using. If you are doing that live broadcasting or live streaming on Facebook, your mobile's Facebook application will convey these details to Facebook application server. Hey, I require this much amount of traffic, this much amount of data rate I require. It kind of conveys that to the application server. Then application server in turn will go and speak to application function, convey these details. Hey, uh, for a subscriber who is starting the live streaming, that guy requires this much amount of uh, data rate or this particular quality of service implementation. It conveys the details to application function. So ultimately, application function can get these details from either from the mobile directly or from the application server initiated by application server or application server pushed by mobile. Either way, depends on the coordination going on between them. But somehow when application server gets it, this quality of QoS flow requirement, it sends this to PCF. It tells the same thing to PCF. Application function tells this to PCF. A PCF, I know that you are the one who will kind of give the permission to create a quality of service flow and generate its billing rules. And if I tell this to SMF anyway will come to you for your permission. I know that. That is why I'm directly giving it to you. So I'm telling you that there is a quality of service flow that is required for the subscriber. So you please, you please take up that activity and generate something called as PCC rules. It application function tells this to PCF. So in the third step, if SMF got this quality of service flow requirements from the mobile, or when the PCF already got this quality of service flow requirement from application function eventually, in either case, PCF will generate PCC rules, policy and charging control rules, and send that policy and charging control rules to SMF. And that rule distribution can be either one step or two step. If SMF got to know about the QoS flow implementation requirement, it will kind of request it from PCF. PCF sends the PCC rules. So it is a two-step procedure. But when AF pushed the PCF to do it, when AF informed the PCF that there need to be a quality of service flow that need to be implemented for the subscriber, it is demanding the PCF to take care of it. PCF will send this in single shot. He himself, on its own, it will send a message to SMF, the PCC rules. It kind of gives a hint to SMF that, You might not have received the information from the mobile to create a quality of service flow, but I got that information from the application function, which is the mediator here between me and everybody that is involved in the quality of service decision making components, that is mobile application server. So that guy told me, I'm telling you, I'm sending you the PCC rules. So this particular QoS flow need to be created with what quality of service, and this must be built by using which billing rules. So these two things together are called as PCC rules: quality of service that required to be implemented, and what is the billing that must be done. So either it can be requested by the mobile, these details, these PCC rules can either be requested by, sorry, SMF, or it can be pushed by PCF on its own. Either way, it will happen. Ultimately, in the third step, SMF gets the rules, the needed PCC rules for the quality of service flow that is getting set up. So now SMF got the permission from the PCF to create the quality of service flow, and that quality of service flow is going to be created with what QoS properties, and how the billing should be done for it. Everything it know. SMF know that. So what does SMF do here? Now it triggers the quality of service flow creation. What it does? It sends this quality of service flow related details. It will send to mobile. It would send to GNodeB. It would send to the UPF. The three major components that are involved in all the complete filtering process. So it would send these QoS rules or QoS profile or your SDF template rules. It will start distributing these things to different entities that are involved in this QoS flow related operation. So SMF will start distributing them details in the fourth step. So now I will not elaborate the first three steps uh, any further than this. But the fourth step we'll elaborate a little bit. We will actually study a little bit more. So as part of the fourth step, PCF detected the PCC rules, what quality of service must be implemented for the QoS flow that is coming up, and how the billing should be done. SMF will send some information to UDF called as SDF template. Hey, how many SDFs are going to go inside this QoS flow? What are the IP flows that are going into this QoS flow? And when you detected the data that belongs to QoS flow, how the billing should be done. So it will kind of provide the billing rules information to UPF. The information would be sent from SMF to UPF in the form of something called as SDF template. How the filtering should be done, which SDFs? Please remember, SDFs are nothing but IP flows only. They are just technically named as SDFs, stands for service data flow. In simple terms, that is IP flow. That is your IP packet or IP flow in simple terms. So which IP packet flows are going to go on this QoS flow? What are that IP packets, IP addresses, port numbers, etc.? The details, the complete information would be sent from SMF to UPF. Hey, these are the filtering rules, man. Take it, use that filtering rules, filter the traffic that is incoming. Any IP packets that are received, I know that you have to put it into a QoS flow, but only if the IP packets arrive for any one of these two SDFs, which are identified with so-and-so IP addresses and so-and-so port numbers. Only those things you detect and send it on this QoS flow. So definitely UPF will identify that QoS flow ID, pack the information, and it will be able to send to the GNodeB. Similarly, yes, SMF, with the help of AMF, it would be able to speak to GNodeB and provide the quality of service profile to GNodeB. In this QoS profile, SMF would tell the GNodeB how many radio bearers need to be created for this QoS flow, whether a new radio bearer need to be created or not, or is this QoS flow is going to share the same radio bearer. So that kind of information it sends in this QoS profile. SMF sends this to GNodeB. Based on that, GNodeB will take care of creating the corresponding radio bearer. If requested, for a new QoS flow that is coming up, GNodeB can create a new radio bearer on top of the existing radio bearer. It can create one. And in this uh, QoS profile, complete details will be there. For this particular quality of service flow, what is the data rate that is applicable? What is the priority of the data? Um, what is whether it is a guaranteed bitrate one or not? Lot of properties related to that quality of service. All the details would be sent to GNodeB. Based on that only, based on that quality of service profile only, GNodeB would be creating the corresponding data radio bearers and setting up the logical channel priorities and logical channel data rates and so on. GNodeB would decide everything based on this QoS profile that is being sent to him by SMF. So all the MAC implementation, whatever the rules that GNodeB's MAC layer and UE's MAC layer have to follow related to QoS implementation, that information would be there inside this QoS profile. That complete details will be there. It kind of gives you everything. It kind of tells you what quality of service must be achieved, what is the data rate at radio level, and everything. Every important aspect related to it. There are a lot of properties in the QoS profile which we will study. But that information goes there. QoS profile. Next, SMF, with the help of AMF and GNodeB, SMF would be able to send quality of service rules to the mobile. In this quality of service rules, once again, it will send the information related to how many SDFs are going to share this QoS flow, what are their IP addresses and port numbers, the corresponding filter level details would be sent to the mobile, and what is the QFI ID, etc. These things are going to be shared from SMF to mobile. So SMF is kind of a component that is distributing same information to everybody, so that everybody in the same line, they know now the working properties for this particular QoS flow that is getting created, that is getting set up freshly. So they can do their duties. So mobile can perform uplink filtering based on the QoS rules provided by SMF. GNodeB, based on the QoS profile, it can set up the radio bearers with particular quality of service implementation. And UPF can do the filtering by using this SDF template information, by using the IP addresses and port numbers that are sent to you by the SMF for this QoS flow. So ultimately, all the three components that are required to participate in this quality of service flow detection and sending the data on the quality of service flow by using specific radio bearers, they will get important packaged information from SMF. So SMF is pretty important here, and the names of these three packages are different. SMF to mobile, we call it as QoS rules. SMF to GNodeB, it is called as QoS profile. SMF to UPF, we call it as SDF template, but ultimately all the information is like kind of similar. Only thing is this SDF template and QoS rules are almost the same. They will mostly contain IP addresses and port numbers, by using which how can you detect the downlink traffic and map it to QoS flow, or how to map uplink traffic to QoS flow. That is what will be conveyed normally when the QoS rules are SDF templates. But QoS profile will be much more. QoS profile will contain what is the data rate that is applicable for this data radio bearer, and what is its priority, allocation, retention, priority, and so on. Lot of other quality of service properties would be sent. Based on it, the data bearer would be set. But all that quality of service implementation is not required on N3 tunnel, because N3 tunnel is basically IP based tunnel, where the quality of service would be provided only on the IP packets DSCP information, which we have learned in our first class. So you don't require to provide data rates or anything on the tunnel. That is automatically done with the DSCP. So how that is done, again at the tunnel level, we'll study in our tomorrow session, how the quality of service implementation takes place on the N3 tunnel. But for radio bearers, a lot of details need to be provided. Based on it, G-Node decides the radio bearer properties while creating the radio bearer. Remember now, what is the meaning of creating a radio bearer? Creating a radio bearer is equal to creating PDCP RLC entities on G-Node, PDCP RLC entity on the mobile, MAC quality of service implementation on G-Node, MAC quality of service implementation on mobile, physical layer properties on G-Node, physical layer properties on the mobile. Everything together is only what we call as radio bearer. So a setting up of a radio bearer is setting up the PDCP work, RLC work, MAC layer quality of service implementation, what data rate, whether it is guaranteed bit rate or not, etc., etc. All these things need to be implemented. That is the only separation between these three different radio bearers. The quality of service for this, the quality of service for this would be different, maybe different, mostly different. So there are three different quality of services. The quality of service differentiation comes at the MAC layer, even though not at PDCP and RLC. PDCP kind of takes care of security and compression. RLC kind of segments and packs the data into a transport block. But actual quality of service implementation takes at MAC. But definitely the MAC behavior while taking the data from these different radio bearers into transport block, that is different. Transport block rules are different for different radio bearers based on their properties or priorities. So this will be associated with a priority. This is associated with another priority. This is associated with another priority. So there can be three priorities in place for three logical channels that are arriving from three different RLCs. So G-Node, when it is requested with the help of QoS profile, that it need to create a data radio bearer, it need to set up this whole thing. It need to set up PDCP, RLC, it need to set up MAC configuration for that radio bearer, physical layer configuration, everything it need to set up, both on its own protocol stack as well as on the mobile equipment's protocol stack. Of course, G-Node would speak to mobile. G-Node's RRC would speak to the mobile's RRC and kind of convey these details. But to create such a radio bearer, first of all, G-Node need to have that information available. Who is going to give that information to G-Node? SMF. In what form it is going to give the information? QoS profile. You have to remember that. So after this QoS rules, QoS profile and SDF template are set, after the fourth step is completed, now you can take it for granted that already quality of service flows are created with some particular quality of service implementation, and everybody know about which quality of service flows are mapped onto which data radio bearers, because everybody got the information related to it from distributed by SMF. So what do? They participate in the actual activity of when the IP flows are received, they would be first level filtered and decided to be sent on three QoS flows. For example, five IP flows sent on three QoS flows, wherein two QoS flows may be sent on one data radio bearer, which is one AN resource, nothing but a data radio bearer. Another QoS flow is going on another data radio bearer, AN resource. So we are using two radio bearers for three QoS flows, but totally five IP flows, data packets from applications in either direction. But this is the AN node, which is nothing but G-Node. G-Node extracts the data out of two radio bearers, but three quality of service flows. but all the quality of service flows would be carried on one single tunnel from AN to UPF. All these things will go on one tunnel or the tunnel specific, the tunnel that is specific to PDU session, because each PDU session contains one tunnel on N3 level. On the tunnel, the data travels. But once it is received at UPF, UPF receives the data in three QoS flows. It will use that QoS flow IDs that are received in the header to do the billing operation, because UPF has been told to bill according to QoS flow IDs. So when it receives in uplink traffic, by identifying the QoS flow ID present in the header, it does the billing activity. After the billing, it will dismantle them from the QoS flows and it will separate them and send it out towards the packet data network. Or if it is downlink, again 5 IP flows, they are being filtered by using packet data rules, PDRs, we call it as, which is nothing but classifying the packets into QoS flows marked related actions, so the filtering rules. Another name is PDRs. A lot of names are there for the same thing. So it will kind of get confusing at one point in time. And then those filtered data would be sent on one tunnel on these data radio bearers and sent out. So, but they arrive on a single tunnel, but multiple data radio bearers can be there. There can be two QoS flows going on one data radio bearer, one QoS flow going on another data radio bearer. It again decides based on the live situation and the properties of the data that is getting carried. On the receiving side, we again split them, segregate them, and send the data to the corresponding applications. So So we have QoS rules and PDRs at both mobile and UPF. And we have mapping of quality of service flows to AN resources, nothing but radio bearers. AN resource is nothing but a radio bearer here on the radio network part. Okay. Now we have a lot more subject to discuss. Actually, the thing that we have to concentrate a lot is nothing but this uh, QoS profile information. What kind of details that will carry, how that QoS profile information will enable the GNodeB to send these data radio bearers and so on. That part, how mobile will convert these QoS profile details to different radio bearers, or how it will decide to create different radio bearers based on these instructions. So we need to understand that. For that, we need to inspect this QoS profile. So we kind of study that QoS profile mechanism. Will not be able to, even if we start today, will not be able to complete today because a lot of details are there in it. So because we can even spend only half an hour extra, even if you continue, what do you guys say? It kind of takes 1 hour. Can I continue till 2:30? If you say so. People respond. Can you spend up to 2:30 so that we can cover up that QoS profile part at least today?
Tomorrow will be fine.
Tomorrow we'll continue. Okay. Mhm. We have a test also today related to PDCP. Okay, we'll not be able to manage everything then. We'll do one thing. Um, we'll not hurry burry go through it. Even if I spend 1 hour time, I may not be able to complete it thoroughly. So what do I do is today we will continue the test, the PDCP test. We take a break for 15 minutes and we come back, we take up the test. That itself will take time for us, up to 215 or so. So this QoS